Looking for projects for your academics? Need help with your project? Want any pre-built project? Then you are at right place. Welcome to my channel, Project Solutions Hub. Hey everyone, and welcome back. Are you just starting your machine learning journey? Especially as a B.Tech CSE student looking for your first hands-on project. Today, we're diving into the classic Hello World of ML, Iris Flower classification. It's simple enough to grasp the fundamentals, yet powerful enough to demonstrate a complete machine learning workflow. Let's classify some flowers. The Iris Dataset is famous for a reason. It's perfectly clean and straightforward, allowing you to focus on the core concepts without getting bogged down in complex data cleaning. With this project, you'll learn supervised learning, training a model with labeled data, classification, predicting discrete categories, in this case, flower species, basic data analysis, understanding your data before building models. It's the ideal stepping stone before you tackle more complex problems. First, let's get our data. The Iris dataset is so fundamental. Scikit-learn conveniently provides it built in. We import load_iris, and then convert it into a Pandas data frame for easy manipulation. We also map the numerical species labels, 0, 1, 2, to their actual names like setosa, versicolor, and virginica for better readability. When we run this section, you'll see our initial output. This tells us we have 150 samples and 6 columns. And here's what the first few rows look like. You can see the measurements like sepal length, sepal width, petal length, petal width, along with the numerical species label and its human-readable species_name. Next, Exploratory Data Analysis, or EDA. This is where we get to know our data. df.info gives us a summary of the data frame, showing us all columns are non-null and their data types, confirming a clean dataset. df.describe provides basic statistics, like mean, standard deviation, and min-max values for each measurement. Crucially, we look at the species distribution. Unlike the fraud detection project, here we have a perfectly balanced dataset with 50 samples for each of the 3 species. This simplifies things, as we don't need special imbalance handling. Now let's visualize. This pairplot is incredibly powerful. It shows scatter plots for every combination of features, color-coded by species. You can clearly see how setosa is well separated from the other 2, while versicolor and virginica have some overlap, especially in features like sepal length width. This gives us insights into how separable our classes are. These box plots further illustrate the distribution of each feature per species. For example, setosa has much smaller petal lengths and widths compared to the other 2, making it easily distinguishable. With a good understanding of our data, we move to preprocessing. This simply means separating our features x, which are the measurements, from our target variable y, which is the species. Then, we split our data into training and testing sets using train_test_split. We use test_size = 0, 3 to allocate 30% of data for testing, and random_state = 42 for reproducibility. Importantly, we use stratify = y to ensure that our training and testing sets maintain the same proportion of each species. The output confirms our split, and checking the class distribution in our split sets. Perfectly balanced, ready for training. Now for the core of machine learning, model training. For this classification task, we're using a decision tree classifier. Decision trees are intuitive because they make decisions by asking a series of questions, much like how we might categorize things ourselves. We initialize our decision tree classifier with random_state = 42 for consistent results. Then we simply call the fit method, passing in our training features, x_train, and their corresponding species labels, y_train. Behind the scenes, the model is now learning the patterns and rules from our data to distinguish between the 3 iris species. After training, the big question is, how well did our model perform on new, unseen data? We evaluate it using our test set. First, accuracy. An accuracy of nearly 98% is excellent. This means the model correctly predicted the species for about 98% of the test samples. Next, the classification report. This report gives us a deeper dive per class. Precision. Out of all predictions for a given species, How many were actually correct? Recall. Out of all actual instances of a given species, how many did the model correctly identify? F1 score. The harmonic mean of precision and recall, balancing both metrics. For a balanced dataset like Iris, high values across all these metrics for all classes indicate a strong model. Finally, the confusion matrix. This is a visual summary of our model's predictions versus the true labels. Diagonal elements. These are the correct predictions. You'll see high numbers here. Off-diagonal elements. These are the misclassifications. For example, if a versicolor flower was wrongly predicted as virginica, ideally, these should be 0 or very low. For Iris, you'll likely see a very clean matrix with high diagonal values and very few, if any, errors. One of the coolest things about decision trees is that we can actually visualize their decision-making process. Each box in this diagram is a node. The top node is the root, the first decision the tree makes. It asks a question like petal width, cm, equals sign 0.8. If the answer is true, you go left. If false, you go right. Each subsequent node asks another question until it reaches a leaf node, a box with value equals x, y, z, which represents a final prediction for a species. The Gini impurity measures how mixed the samples are at that node. 0 is pure. Samples is the number of data points. Value shows the count of each species. Class indicates the predicted species for that node. This visualization makes the model's logic transparent, which is incredibly valuable for understanding how it arrives at its predictions. So, that's the Iris flower classification project. It's a fantastic hello world that introduces you to the entire machine learning workflow, from loading and exploring data, training a simple yet powerful model, evaluating its performance, and even peeking into its decision-making logic. This project is your perfect foundation for more complex ML challenges. If you found this guide helpful, please give it a thumbs up, share it with your friends, and subscribe for more in-depth B.Tech CSE project tutorials and machine learning insights. Happy coding, and keep building amazing things. Thanks for watching. Keep learning with Project Solutions Hub. And don't forget to like, share, and subscribe.